Good morning, everyone. So today we are going to be working on a few problems. One of them being how to find the force of gravitation, the universal law of gravitation, how to find the force, how to find a mass, and how to find how far they are. The last question that we're going to go over is the relationship question between kind of what happens when you double mass, what happens when you double distance, and how does that affect the force of gravitation. Okay, so let's go ahead and get started. The first one says, how far apart are two objects if they have a mass of 45, if they both have a mass of 45 kilograms and feel a force of 0.0012 newtons? So looking at this problem, right, we start with, every time we do any of these problems, we start with knowns and unknowns, right? So what's given to us in this problem is both m1, m2, and the force of gravity. Right? So M1, it said it was 45 kilograms for both of these, right? And the force of gravity, I don't remember off the top of my head, so let's go check that out, is 0.0012 newtons. So 0.0012 newtons. Okay, so let's figure out how to solve that. So what we're looking for, right, is we're looking for how far apart these two objects are. So the equation for this is Fg is equal to capital G times m1 times m2 all over distance squared. So just plugging in our knowns into this equation, you get 0.0012 is equal to 6.67 times 10 to the negative 11th times m1, which is 45, times m2, which is 45, divided by d squared. So solving this out, you could do multiple ways to solve this. What I'm going to do is, because these two are kitty corner from each other, you can actually flip these two terms. So the process would be to multiply d squared to the other side, multiply d squared to the other side, and then in the same step, you would divide 0.002 to both sides. So the new formula would be d squared is equal to 6.67 times 10 to the negative 11th times 45 times 45 divided by, right, 0.0012. So now all you need to do is simplify this in your calculator, and we'll take the square root. So let's go ahead and do that. So taking your calculator, right, you get, in parentheses, 6.67 times 10 to the negative 11 times 45 times 45 divided by 0.0012. And you click enter. So what you'll get for the right hand side, right, so you get d squared is equal to 0.10001125556. So now you're not done, right, because you do need to take the square root. So taking the square root of that number, wrong button, I keep pressing the wrong button, sorry about that. So the square root of 0.000112556, you'll get distance is about 1 centimeter. So 0.0, sorry, not 1 centimeter, 10 centimeters. 0.010 meters is the how far apart these two objects are. Good, so go ahead and pause the video here if you would like to write this down in your notes. I'm going to go ahead and move on to number 2. So number 2. So number 2 says, what is the mass of a comet if it is orbiting a planet with a mass of 2.37 times 10 to the 19th? If the object is 375,000 meters away from the center of the planet, and it feels a gravitational force of 3,750. So looking at this, I'm just going to do knowns and unknowns, and then we'll move back to my writing. So I have knowns and unknowns. What we know, right, that first number represents a planet that, so we're going to call that M1, that is rather large, so 2.37 times 10 to the 19th kilograms. The next thing that we know is the distance is 375,000 meters away. And then the force of gravity, is 3,750 newtons. So what we're looking for in this case is we're looking for M2, right? The mass of the actual comet. So the second thing. So here's what I got so far. So looking at this, I'm going to try to move this up slightly, just so we can see it. Perfect. All right, so what we have for here, we have, again, just the same equation. Fg is equal to capital G times M1 times M2 all over distance squared. Okay. Good, and then let's plug in our nodes and unknowns. So Fg is 3,750. Capital G is 6.67 times 10 to the negative 11th. M1 would be 2.37 times 10 to the 19th. And we're looking for M2, the mass of the comet. And now the distance is 375,000 meters away, and just make sure you square that. Okay, so working with this, we can move the distance over to the other side. The way I like doing it is just simplifying these three terms, so multiplying the top two and then dividing by the bottom squared, and you'll have one discrete line going across. And I'll show you how I do it just with one step in the calculator. So taking your calculator, right, open your parentheses, 6.67 times 10 to the negative 11th times 6.67 times 10 to the, I forgot the parenthesis, negative 11th, close parenthesis, open parentheses, 2.37 times 10 to the 19th, close parenthesis. Don't click enter just yet, but divide this by 375,000 squared. And now you get one number, right? So you get 3,750 is equal to this number, so 0.01. I'm going to try to keep a little bit of digits just to be accurate. 11241 M2, right? So because those two are being multiplied, the next step, right, would be to divide this number to the other side. Divide this number to the other side, so 0, 0, 1, 1, 2, 4, 1. So 3,750 divided by the number that we wrote down. So 0.011241. And you're going to get 333,600 kilograms. And that is the mass of the comet. Good. Okay, so let's go through. Question number 3, and then we'll briefly talk about question number 4. So question number 3 talks about, right, what would the force of attraction of two objects be if in space, if there are 30,000 meters apart? One object has a mass of 4.5 times 10 to the 19 kilograms, and the other has a mass of 6,000 kilograms. So this one, we're just looking for force, right? So let's go ahead and do the knowns and unknowns for this. Perfect. And you have, so what's given is distance is 30,000, right, meters. The mass of one object, or it's a rather massive object, is 4.5 times 10 to the 19th. And then the mass of the second object is 6,000 kilograms. Okay. What we're looking for is that force of gravitational attraction. Okay, so going back to, right, how do we solve these? I have my knowns and unknowns already, right? These we got from the problem, and now it's just a matter of getting your equation in line. So you have Fg is equal to m times m1 times m2 all over distance squared, and then just plug in your knowns and unknowns. So Fg is equal to 6.67 times 10 to the negative 11th times M1, which is 4.5 times 10 to the 19th times M2, which is 6,000. And we're going to divide that by 30,000 squared. Okay, so before we simplify this, I'm actually going to show you how to do this in one step in your calculator and how to type it in. And you would really just need to do this in one step. So taking your calculator, right, clear it from the previous problem, open parenthesis, just go 6.67. So type in what you see at the very top line, so times 10 to the negative 11th, 4.5 times 10 to the 19th, and then type in, right, multiply that by 6,000. So now that you have that, right, you could divide that by the bottom. Just make sure you have parentheses. So 30,000, right, squared. So this is just going to let you do this in one whole step. So let's go. Let's scroll back so we can see what I did. Right, I just typed in the top first number. Right, multiply that by the second number. Okay, then we have times 6,000 divided by 30,000 squared. When you click enter, that's your actual answer. Right, so the force of gravity is going to be 20,010 newtons. And that is your final answer. Okay, last thing I want to talk about are the relationships. And the relationships, right, it goes on and asks, what would happen to a force, right, if you double the mass? So very similar to the force of electrostatics, right? If you think about that equation, you have G times M1 times M2 all over distance squared. So if it's on the very top of this equation, it has a direct relationship, right? So as one goes up, the other goes up, and it goes up in a linear fashion. If it's on the bottom, it has an indirect relationship. So what's happening here, right? If you double M1 or M2, right, that's going to cause FG to double. If you triple, right, M1 or M2, that's going to triple FG. Okay. Now, distance, right? This is an inverse relationship, and it's also squared. So make sure you keep that squared factor in there. So when we talk about distance, right? If we double distance, then FG will pretty much go up by whatever factor squared. So if you think about doubling, it's a factor of 2. Make sure you square that, so it's actually going to quadruple. If you triple distance, right, then FG is going to, right, 3 squared, go up by a factor of 3 squared, which is, it's going to go up by a factor of 9. Okay, everyone, so just make sure that you have this in your notes, and I'll see you all in a bit. Thanks.